increments or iterations or chunks and built and tested in those chunks, one chunk at a time. Oftentimes, the organizational principle used there is the most important features are built first, so that if we were to run out of time and have to skip some of the later iterations, the core value of the project could be delivered into production. And that's a key piece of this. If you're doing this properly, at the end of each iteration, you have something that is production ready in terms of its quality. If that's not the case, then you're not actually following an iterative approach. You have to have something that could be delivered into production. It's of a sufficient level of quality and delivers something of value. Otherwise, you're in some sort of mongrel version of a sequential iterative type of approach that's going on. So this relieves some of the issues, but not all of the issues, and it brings with it its own set of challenges that have to be planned and managed from an organizational point of view. One is anticipating and dealing with the regression issues that are going to arise. So if each increment is tested on its own at the end of that iteration, and we're now production ready, as code starts to come along from the next increment, that, of course, destabilizes the code from the previous increment or increments, right? Anytime we're making changes to an existing code base, there's a potential for regression in that code base, whether that code has ever actually been put into production or not. I think this is something that people get confused about because they think, well, regression testing is testing features that are already in production to make sure they still work. Well, no, in this case, the regression testing would also include everything that had been built in the previous increments and everything that was already in production if you're doing a maintenance release, right? So what you're going to have is this sort of telescoping amount of regression testing that has to occur. By telescoping, I mean that each increment, it's going to increase because you're going to have regression testing of the previous increment and the increment before that, and so on and so forth, all the way back upstream. And if you forget this, what you'll find is that while the features flowing into each increment may be constant in number, the amount of testing effort required for each increment is going up because of the regression test needs. So a purely manual approach to dealing with regression testing is not generally successful in these. You have to look at some form of automation to try to attack this, either automation at the system level or automation at the unit level. Now, theoretically, if you're following an incremental approach, then the increments are supposed to be, ironically enough, I guess, sequential. In other words, the whole team moves from one increment to the next together as a team. But what we see in some of our clients is a decision to start to do overlapping of increments. In other words, as the business analysts finish up the requirement specification on increment N, they move on to start doing the requirement specification for increment N+1. Similarly, the designers and architects, when they get done with the design work for increment N, move on to N+1. And the coders, likewise, moving on to the implementation work for the next increment before the testing work of the previous increment is actually done. This seems like it would theoretically increase the efficiency of the operation of the project, but what ends up happening is that the testers, of course, find bugs, right? That's what we do. We find bugs. Now, the people who are needed to respond to those bugs, the analysts, the architects, the designers, the coders are off doing something else. They're not available to respond effectively to the bugs. Or if they do get pulled into that, they, of course, feel overcommitted, wishboned, right? And thus they do a bad job of both. Bad job of both the work on the next increment and a bad job of responding to the bugs we found on this increment, which of course leads to more bugs, which creates a vicious cycle where everything starts to slow down. So it's important to not do that, to think about what's a realistic number of bugs that are going to be found during the testing of each increment, and how is that going to load non-test people in the organization. And if that's not planned for, then that's going to create a lot of organizational stress, which again is morale problems, turnover problems, etc. Now, you can also get overcommitment and long hours, not out of a failure to recognize that there are going to be bugs, but just the classic software engineering mistake of overcommitment. If you've ever read Fred Brooks' book, The Mythical Man Month, he talks about trying to put 20 pounds in a 5-pound bucket. And so this is something that's been going on, forever in software engineering. The business wants what it wants, and the business only wants to pay so much for that. And those things are almost always in conflict, no matter what business you're in. You're the mass market software business, you're in the enterprise software business, you're in the IT business. I mean, we see this around the world across all our clients, this tendency to ask for more than can actually be accomplished given the resources, right? And you guys know this, you live it all the time, right? And so then, you still get overcommitment, you still get long hours that come out of this, except that now the long hours are happening continuously throughout the project because each iteration is overcommitted, right? So instead of the B model thing where everything's fine until the end of the project and then all of a sudden it's a disaster and we're way overcommitted, right, and the long hours kick in, here you're going to see something where at the end of each iteration there's a mad scramble and long hours, which can be even more disruptive to morale. We've seen this with some of our clients that are following this approach, and it's a real burnout machine. If at the end of every iteration you're going to go through this huge mad scramble, 60-hour weeks, working Saturdays, working Sundays, that kind of thing. So you have to try to inject some realism. There has to be a process for triaging features from one iteration to the next if it becomes clear that the overcommitment has occurred. Oddly enough, one of the problems that you might think we were trying to solve with an iterative model can even happen with iterative models, the late involvement of the test team. Now you might say, well, how can that happen? Well, that oftentimes gets back to the overlap of increments. If the test team is fully engaged trying to finish up the testing of increment N, while the design and analysis work is going on increment N+1, obviously the test team has no time to participate in reviews and so forth, right? So this just pulls us back into the same problem we had with the V model potentially of lack of adequate early QA and testing then leading to the same kind of big explosion of bugs during the system test at the end. So these models, iterative and incremental models, can help, but we have seen with a number of our clients the misapplication of them that results in a lot less efficiencies than people thought they would get. Okay, so Agile models. Now, Agile can be thought of as a form of iterative, but I think it's worth addressing it on its own because it has its own particular challenges, potentially above and beyond what might come from any other iterative approach. And I want to point out something. Just like there's incremental models as they are theoretically conceived to be and incremental models as they are actually practiced, we see a lot of that with our clients that are using Agile too. There are fairly clearly defined rules about what you're supposed to do if you're following an Agile lifecycle model, and a lot of controls in it to try to keep it pointed in the right direction. But what we see in actual practice with a lot of our clients is that they pick the parts of Agile that they like, they drop the parts of Agile that they don't like, and they still call it Agile. So what I'm referring to here in terms of the challenges are Agile as we actually see it practiced by our clients around the world, not Agile as it exists in some rarefied, theoretical existence or in the training course, right? You can go out to agilemanifesto.org and read how it's supposed to be, but then when you get down to people using it on projects, you find that it's often